Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into the groundbreaking results from DeepSeek's R1-Zero and R1 reasoning systems, and what they mean for the future of AGI. The ARC Prize, a competition focused on pushing the boundaries of AI, has just released its analysis, and it's electrifying.
Absolutely. I'm buzzing about this. The ARC Prize has always been a great indicator of real progress, not just hype. So what's the big takeaway from this DeepSeek research?
The core finding is that R1-Zero, a system trained without human supervision, no supervised fine-tuning or SFT, performs surprisingly well on the ARC-AGI-1 benchmark, achieving around 14% accuracy. This is comparable to R1, which did use SFT, scoring 15.8%. This challenges the prevailing assumption that human labeling is essential for high-performing reasoning systems.
That's a huge deal. It suggests that reinforcement learning alone can drive significant progress, removing a major bottleneck in the development of these systems. But how does it compare to other systems, like OpenAI's O1 and O3?
Exactly. Compared to OpenAI's O1, scoring around 20 to 35% depending on compute, R1-Zero is competitive, especially considering its significantly lower cost. And while O3 boasts impressive 76 to 88% accuracy, it uses both SFT and extensive search/sampling, making it far more computationally expensive. R1-Zero's simplicity is remarkable.
So what are the implications of this SFT-free approach? Is it a game changer?
It's a massive step towards more efficient and scalable AGI development. The analysis suggests that SFT is crucial for broader generalization, but for specific domains with strong verification mechanisms, like math or coding, it might not be strictly necessary. Think of it like this. R1-Zero creates its own internal language, a domain-specific language, to solve problems. It's incredibly efficient, but perhaps less adaptable to completely new tasks.
I see. So R1-Zero is a specialized tool, while systems like O3 aim for broader applicability. But the efficiency of R1-Zero is undeniably attractive. What about the economic implications mentioned in the analysis?
The analysis highlights two major shifts. First, the increasing willingness to spend more on inference for higher reliability. Users are prioritizing dependable results over raw accuracy. Second, the emergence of inference as a training method. Reasoning systems can generate high-quality training data, creating a positive feedback loop. More users pay for inference, generating more data, improving the model, attracting more users. It's a virtuous cycle. It's a really exciting development.
It's almost like a self-improving system, fueled by economic incentives. That's a fascinating perspective. But what about the limitations of R1-Zero? The analysis mentions some challenges.
Right, the paper notes that R1-Zero sometimes produces less readable output and mixes languages. However, the ARC Prize testing found this wasn't a major issue on ARC-AGI-1, which focuses on mathematical and coding problems. It's a trade-off. Incredible efficiency for potentially reduced generalizability. It's something to keep an eye on.
So the future looks bright, but there are still challenges to overcome. What's the next big step, in your opinion?
I think the next frontier is to see if we can achieve on-3 level performance without SFT, using a purely RL-based approach like R1-Zero but scaled up. If that's possible, it would be a monumental leap forward. And the open-source nature of R1 will undoubtedly accelerate research in this area. It's a very exciting time for AI.
Absolutely. This research is a significant contribution to the field. Thanks for breaking it down for us.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We'll see you next time for another dose of cutting-edge tech news. Goodbye.
Bye-bye.